All right, today we're going to dive into one of the most powerful and, honestly, elegant ideas in all of ecology, the ecological niche. We're going to see how a single concept totally transformed our understanding of how life on Earth is organized. And it all comes down to an idea called the n-dimensional hypervolume. Let's jump in. So let me ask you something right off the bat. When you hear the words ecological niche, what pops into your head? Is it just an animal's habitat? A lion on the savanna, a polar bear in the Arctic? It's a really common way to think about it, but believe me, it's just a tiny little piece of a much bigger and way more interesting picture. See, that's the thing. A niche isn't just about where an organism lives, its address. It's about what it does for a living. It's about its profession. It's the sum total of all its interactions, its role in the ecosystem, its entire playbook for survival. And the person we really have to thank for this total mind shift is G. Evelyn Hutchinson, way back in 1957. He's the one who came up with this revolutionary idea that a niche is an n-dimensional hypervolume. Now, I know, that sounds incredibly complicated, right? But stick with me, because the idea behind it is actually beautiful and surprisingly simple. Let's break it down. Okay, so here's the absolute key takeaway. For just a second, forget about the habitat. The niche is the functional role a species plays, plus all the different environmental conditions it needs to survive and reproduce. It's not just the address, it's the full resume and the complete list of must-haves for a living. And this is where we get to the really cool part, actually building this so-called hypervolume. I mean, how on earth do we even begin to visualize something with n dimensions? Well, imagine we're drawing a graph. But instead of just your typical x and y axes, Hutchinson said, hey, let's add an axis for every single environmental factor that matters to a species. Temperature, that's one axis. Humidity, that's another. The size of the food it eats, that's a third axis. The pH of the water, the salinity, and on and on and on. The specific zone where a species can survive across all of these dimensions, that is its hypervolume. This brings us to a really crucial distinction, something ecologists talk about all the time, the difference between the fundamental and the realized niche. So think of the fundamental niche as the absolute maximum, the full theoretical range of conditions where a species could thrive if it had the whole world to itself. But, in the real messy world, you've got predators, you've got competitors, and all that pressure shrinks the possibilities. That smaller space that a species actually occupies in reality, that's its realized niche. Okay, so this hypervolume idea is cool and all, but can we actually measure it? Can we put numbers to it? You bet we can. And that brings us to two really important metrics that help us understand how different species interact. First up is something called niche width. And you can basically think of this as a measure of how picky a species is. Does it have a really wide tolerance for different foods and temperatures? Or is it super, super restricted? This one measurement tells us a ton about its overall strategy for survival. And this table just lays it out perfectly, right? On one side, you have the generalist, like a crow or a cockroach. With a really broad niche, it can eat pretty much anything and live almost anywhere. Then, on the other extreme, you have the specialist, like the giant panda, with a razor-thin niche. Its survival is almost completely tied to one thing, bamboo. So you can see how this single metric reveals so much about how adaptable a species is. And the second key metric is niche overlap. Now, this is where the drama happens. This is the zone where the hypervolumes of two different species intersect. It means they're both trying to use the same limited resources, whether it's the same food, the same nesting sites, you name it. And wherever you have overlap, you're gonna have competition. So that's the big question, isn't it? What actually happens when these niches start to collide? How do entire communities of hundreds of species manage to live together when it seems like competition is everywhere? Well, when that niche overlap is high, the competition gets really intense, and that can lead to a few different outcomes. One possibility? One species is just a better competitor and it drives the other one out completely. We call that competitive exclusion. Or things can get more interesting. The species might evolve to divide up the resources. That's called a resource partitioning. Or they might even evolve different physical traits to reduce the competition, which we call character displacement. And, the classic textbook example of resource partitioning is just perfect for understanding this. You can have several different species of warblers all living in the exact same spruce tree. So how do they do it without driving each other crazy? Well, one species feeds at the very top of the tree, another one hangs out in the middle, and a third sticks to the lower branches. They've cleverly divided up the tree resource, which shrinks their niche overlap and allows them all to coexist.
Pretty smart, right? All right, let's switch gears for a second. Especially for anyone studying this formally, you absolutely have to know how to interpret the graphs that go along with these concepts. So let's quickly decode how all of this is visualized.
When you see one of these resource utilization curves, it's telling you a story. The x-axis at the bottom, that's your resource, say, seed size from small to large. The y-axis shows you how much a species is using that resource. So a really wide, flat curve, that's your generalist, eating a whole variety of seeds. A tall, narrow curve, that's your specialist, focusing on just one type. And that all-important area where the curves overlap, that's your visual representation of niche overlap. The bigger the overlap, the more intense the competition.
Okay, lightning round. Here are the common traps that people fall into. Let's make sure you don't. First, and say it with me, a niche is not a habitat. Second, having a bigger niche doesn't automatically mean having a higher population. And third, just because two niches overlap doesn't mean one species is automatically doomed. As we saw with those warblers, coexistence is absolutely possible.
So let's tie this all together with a nice bow. Remember, Hutchinson gave us the concept of the functional niche, a species' job, not its address. The amount of overlap between these niches tells you everything about the intensity of competition. And the width of a niche tells you if you're looking at an adaptable generalist or a focused specialist. If you can lock in those connections, you've pretty much mastered the core of this. And I'll just leave you with a final thought to chew on. In a world like ours, where climates are shifting and habitats are changing faster than ever, which survival strategy do you think is the better bet? The adaptable, do-it-all generalist, or the highly efficient, focused specialist? The answer to that is going to shape the ecosystems of our future. Thanks for tuning into this explainer.